Congruence. In geometry, two figures that have the same size and shape are said to be congruent. In other words, two figures are congruent if one is an exact duplicate of the other. Look at figures A and B. We can move figure B in such a way that it will exactly fit on top of figure A. Figure A and figure B are congruent figures. However, if we try to do the same thing with figures C and D, we cannot cause them to coincide. Therefore, they are not congruent. Let us now turn our attention specifically to congruent triangles. Two triangles will be congruent if and only if each of the following is true. There is a one-to-one correspondence between the sides of each of the triangles. These sides are called corresponding sides. There is a one-to-one correspondence between the angles of each of the triangles. These pairs of angles are called corresponding angles. And corresponding parts of the triangles are congruent. Fortunately, in order to know that two triangles are congruent, we do not need to know all these conditions are met. There are four sets of minimum conditions for congruence that are frequently used to prove triangles congruent. They are as follows. Two triangles are congruent if each pair of corresponding sides is congruent. That is abbreviated SSS for side, side, side. Two triangles are congruent if two pairs of corresponding angles are congruent and the pair of corresponding sides between those angles is congruent. This is abbreviated ASA for angle, side, angle. Two triangles are congruent if two pairs of corresponding sides are congruent and the pair of angles formed by the sides is congruent. This is abbreviated SAS for side, angle, side. Two right triangles are congruent if the hypotenuse and a leg of one right triangle equal the corresponding parts of the other. This is abbreviated HL for hypotenuse leg. Do not fall into the trap of trying to use angle, side, side, or angle, angle, angle to prove congruency of two triangles. Neither of these will guarantee congruence. For instance, we see that the triangles PQR and PQS both have the angle side-side correspondence with triangle ABC, but only triangle PQR is congruent to triangle ABC. Also notice how triangle LMN has angles congruent to triangle ABC, but that triangle LMN is much smaller in size. We are now ready to begin constructing simple proofs. A proof in mathematics may be thought of as a chain that leads from the given facts to some conclusion. Each link in the chain is a statement whose correctness is supported by a valid reason. Those reasons consist of undefined terms, definitions, axioms and postulates, which are mathematical statements that are assumed to be true, and previously proven theorems. Here is a guide for developing a geometric proof. Number 1, read the problem. Identify what is given and what you need to prove. 2, make a drawing of any figures involved and label each appropriately. 3, write the given facts and what you want to prove. 4, mark the given information on your figure. 5, analyze the problem. 6, make an informal plan. 7, write a logical sequence of statements and reasons leading from the given to the conclusion. Note that statements and reasons are paired together by numbering them. Even though drawings may be beneficial to our work in constructing a proof, remember we cannot use drawings to tell us about size. They can only tell us about relationships among the parts of the drawings. Before you begin your work, consult your textbooks to see what undefined terms, definitions, axioms and postulates, and previously proven theorems are available to you for use in writing your proofs. Let us now develop some proofs. Example 1. Given the following figure with angle 1 congruent to angle 4 and angle 2 congruent to angle 3, prove that triangle ABC is congruent to triangle CDA. We are given that two pairs of angles are congruent and from this we want to develop a logical set of statements that will show that two triangles are congruent. We know of 4 ways to prove two triangles are congruent: SSS, ASA, SAS, and HL. Because we have 2 pairs of congruent angles, let's first look at the possibility of proving the triangles congruent using ASA. In order to use ASA, we need to prove the side between angle 1 and angle 3 is congruent to the side between angle 2 and angle 4. This can be done since line segment AC is congruent to itself. Now that we have made an informal plan, let's write the proof. Statement number 1. Angle 1 is congruent to angle 4. The reason given. Statement number 2. Angle 2 is congruent to angle 3. The reason it is given. Statement number 3. Line segment AC is congruent to line segment AC. The reason, the reflexive property. Statement number 4. Triangle ABC is congruent to triangle CDA. The reason, angle, side, angle. We have reached the desired conclusion and our proof is now complete. Example 2. Given the following figure with line segment AC congruent to line segment AS and line segment RA congruent to line segment MA, prove angle 1 is congruent to angle 3. We are given 2 pairs of line segments congruent, and from this we want to develop a logical set of statements that will show that angle 1 is congruent to angle 3. Sometimes we must first show, as in this case, that 2 triangles are congruent in order to justify the conclusion sought. We know 4 ways to prove that 2 triangles are congruent: side, 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 angle, side, angle, side, angle, side, and hypotenuse, leg. Since we are given 2 pairs of sides congruent, we will look at using either side, side, side or side, angle, side to prove the triangles congruent. Looking at the information given, there is no way that we can conclude that the line segment MS and the line segment RC are congruent. Therefore, we cannot use side, side, side. Upon investigating the use of side, angle, side to prove the 2 triangles congruent, we find this to look promising since angle MAS and angle RAC are vertical angles, and by definition they are congruent. Once we have proven that the 2 triangles are congruent, then we will know that angle 1 and angle 3 are congruent since they are corresponding parts of congruent triangles. Now that we have developed an informal plan, let's write the proof. Statement number 1. Line segment AC is congruent to line segment AS. The reason it is given. Statement number 2. Line segment RA is congruent to line segment MA. The reason it is given. Statement number 3. Angle RAC is congruent to angle MAS. The reason, definition of vertical angles. Statement number 4. Triangle RAC is congruent to triangle MAS. The reason, side, angle, side. Statement number 5. Angle 1 is congruent to angle 3. The reason, corresponding parts of congruent triangles are congruent. This is abbreviated CPCTC. We have reached the desired conclusion and our proof is now complete.